Well, howdy. So let's look at the first thing that we wanted to look at in this lecture. We're going to talk this lecture about um, translational stability, the law of inertia, and things like that. We're talking about basically Newton's first law. So Newton's first law basically tells us the state that everything is in before it interacts with anything else. How something that's isolated, how something that's alone, how does it act? Now, we have some idea about at least one thing, right? And that's what I'm going to start with the stability. I mean, the first part is that when an object when an object is both, say, first, not moving, right? So something's not moving. That's a a coffee mug on a table, and not about to move. I'm not grabbing that coffee mug right now. Then there's no net force on an object, or another way to say that is then any forces on an object and object balance. Okay, so that sort of means, right, if we have our coffee mug, it's still subjected to forces. Things are still trying to do stuff to the coffee mug, right? So we've got gravity trying to pull it towards the center of the earth, right? So that's basically its weight. Whenever you have any sort of weight, you have a force. So if you're sitting in a chair right now, you can feel that you have a weight, basically not because of the weight pulling you down, but because of the chair pushing you up, right? And that's the other force on this coffee mug, right? There's a force coming up here from the table that's preventing the coffee mug from falling to the ground. So that's more or less what we have as a force balance, is that we have one thing pulling, one thing pushing, and they exactly counter each other. That's, in this case, these two forces. Forces are things that pull or push. Or at least that tend to pull and push. And so you can think of these in different ways. Like, we're still looking at things that balance. So if we have a tug of war, right, some stick figures tugging a very fake looking rope, right? There's more rope over there. We've got these guys pulling to the left, these guys pulling to the right, and as long as the guys pulling to the left and the guys pulling to the right are both pulling at the same amount, or the same forces, they have the same strength pull, then nobody gets wet, right? But if one side is stronger, the other side gets wet, and that's the point of that. So the pull by these guys is the force. Now, it's not everything that gives a force is animate, right? So we think of pulls and we think of pushes as animate things, but right, these guys over here, the guy on the right or on the left is not pulling the guy on the right, but if these guys are stronger and they pull the guys to the right, what happens? It's not the direct effect of these guys, it's the effect of the rope on these other people. So it's actually the rope that's pulling these guys. Okay, so that's important to remember, that it's not just animate things that provide forces. And another way to look at that is if we look at a push instead of a pull, right? And do far too many silly things like this where we're pushing boxes or something. If you're pushing a box, but you're not strong enough to make it move, what's happening? Well, you're pushing this way, and the box would want to go this way, except the floor is rough, and the floor is pushing the box that way, which is why sometimes it'll topple over if you can't make it go this way, but if you're up here somewhere, you might actually make this thing topple over and go this way instead. So it depends on what's in the box and stuff like that, how high you push. But in general, the floor pushes on the box just as you push on the box. And so the box doesn't move unless you're strong enough to make the box move. So the floor is inanimate, but it still provides the force. Right? The force has nothing to do with people thinking that they can make things move. All right, so there doesn't have to be a decision to provide a force. And you might think, that's everybody knows that. Dr. Ranchler, everybody knows that, right? Well, that's unfortunately not quite true. A lot of student difficulties come from thinking that only a thinking object can decide to make a force happen. So you have to be careful about that. Okay. So a force on an object is a push or a pull. So I guess that's where we are, right? We have these forces balancing when an object does not move and does not start moving. The only other thing we have to talk about for forces are how they're measured, right? So in SI units, we measure them in newtons. And that's about the weight of a pineapple, I think. So if you go to the store and pick up a pineapple, that's about a newton. And in imperial units, in American units, which are now called imperial, well, I guess they're imperial because they were originally English, and everybody in the empire had to use them. There's something called a pound, or actually we call it a pound of force. So this is a Newton N. This is a pound of force LBF. Okay. Technically, a pound should be force all the time. So when you're weighing something, you're weighing a force. Kind of technically, but it's so common that people use the word pound for weight that a lot of times you'll have something called a pound of mass. And when we get into Unit 2, we'll worry about that. Right now, we don't have to worry about. We're not going to worry about the specific models for each of the forces right now. First, we're going to go through and we're going to talk about forces in general. And I'll just say something provides a force for you. In Unit 2, we'll go ahead and we'll look at each of the forces in detail. No, many of the forces in detail. I guess it's the second half of Unit 2. And talk about, well, what causes, water resistance on a boat that's moving forward? Why does the propeller push the boat forward? What about a sail? How do these things work? We'll look at those sorts of issues in more detail later. Right now we want to just look at these things. So we have a pound, and that's about a weight of a grapefruit. So basically our idea of force is how much something weighs, right? You hold something up, and that's a force, right? Pushing down at you that you have to counteract with your hand and or with your arms, and you're calibrated to figure out if something's more or less. So that lets you feel what a force is. All right. So that is our first thing. So I'll do an example after this. That example will actually be a tug of war between a college guy and his younger cousins. And then we'll go through and we'll look at a rotational version of this. And then we'll talk about the law of inertia itself. We'll talk about Newton's first law in a more general context that will get rid of this condition and just talk about what happens when the forces on an object balance for a moving object. Right? And basically it's going to be more or less the same thing with a caveat on what it does to the motion. All right? And it does the same thing to the motion that this does. That's a clue. All right, that's a clue. Think about that a little bit. If something's moving and it does the same thing as not as if you affect something on something that's moving in the same way that doesn't make something that's not moving start moving, what is that going to do to the thing that's moving? That is a really horrible sentence. So, rewind, rewrite that, try to figure out what I was saying. Think about that. We'll talk about it a little bit later. All right? Talk to you later. Bye now.